Assalamu alaikum everyone. I hope all of you are doing extremely well. So this is our lesson number 1 on AS Organic Chemistry, and I'm your instructor Mariam Shaukat. Today we will be talking about the different formulae which exist in organic chemistry. These are kind of very important, and this is basically just the foundation that needs to be there before we actually start talking about different homologous series and nomenclature and everything. So the first thing that I would want to talk about is the molecular formula. I'm pretty sure that all of you are already aware of it. Now, for all of these examples, for all of these formulas, I will be using the example of pentane and butene, and I'll show you the molecular formula and the other formulas for each one of them. So let's start off with the molecular formula. We say that the molecular formula is a formula that shows us the actual number of each type of atom in a molecule. In other words, the molecular formula shows us the actual number of atoms of each element, because each type basically means each element in a molecule. So, for example, over here you can see that this is pentane. I hope you know the formula for alkanes, that is CnH2n plus 2. You should remember this from your O levels. And so pentane, pent basically means 5. See, it has 5 carbons. So if you plug into this formula C5, you will get C5H12. So that is right over here. So we have pentane. This is the molecular formula, because you can see that in an actual molecule of pentane, you will have 5 carbons and you will have 12 hydrogens. So this is showing you the actual number of each type of atom in that molecule. Similarly, this is butene. I hope you know the formula for alkenes as well, CnH2n, right? So in alkenes, but basically means 4 carbons. So plug 4 in there, you will get C4H8. So now you can clearly see that our basically in our actual molecule of butene, we have 4 carbons and 8 hydrogens. So this is basically our molecular formula. Now the next thing that we will talk about is our empirical formula. Now empirical formula actually shows us the simplest ratio of the different types of atoms present in a molecule. So take for example our pentane. Now in this you can see that the ratio between carbon and hydrogen is 5:12. Now there's nothing common in 5 and 12, or there's no factor that is common to both 5 and 12. So there's no way that I can simplify this further. And that is why you can see that in the case of pentane, the molecular formula and the empirical formula are basically the same. Now, on the other hand, for butene, you can see that our ratio between carbon and hydrogen is 4:8. And they do have a common factor of 4. And so I can take this and simplify this ratio to 1:2. Right? And that is basically the simplest ratio of the different types of atoms, basically carbon and hydrogen in butene. And so the empirical formula for butene is CH2. These are very babyish things that we are talking about, but I want them to be 100% clear in your head. And although you've already done this in O levels as well. Okay, let's now move on and talk about the structural formula. So the structural formula is basically, it tells us about the atoms which are bonded to each carbon atom. Very important statement, each carbon atom in a molecule. Now, because organic is all about carbon and its molecules, we are going to give special preference to each carbon atom and basically see what atoms are attached to each carbon. So for example, in the case of pentane, you can see that this is the structure formula. In this case, you have clearly written out what is attached with each carbon. For example, on this carbon, you can see that we have 3 hydrogens and this one alkyl group. Alkyl, we will discuss this in one of our coming videos, but just to give a disclaimer, and I'm pretty sure that you're already aware of it as well. But alkyl groups are basically when you take an alkene and you remove from it one hydrogen, you are left with an alkyl group. So for example, methyl, ethyl, propyl, and so on. This thing right here is butyl. So this carbon has 3 hydrogens attached and a butyl group. Coming to this carbon right here, let me actually draw it, an arrow there. So coming to this carbon, you can see it has one methyl group, a propyl group, and 2 hydrogens attached with it. Similarly, if I take this arrow and put it here, you can see that this carbon is attached to 2 hydrogens and 2 ethyl groups. And so you basically get the idea, right? That for every carbon, we are clearly showing which group of atoms are attached to it. Okay, so this is for propane. Let's look at butene. Now obviously for butene, the double bond could have been here, it could have also been in the middle, but right now I'm going to talk about but1ene. But1ene basically means that our next video is on nomenclature, so don't worry about the naming yet. But but1ene basically means that the double bond is attached to the first carbon, which you can clearly see over here. Obviously, there's also but2ene, but we're not talking about it for now. Alright, so you can draw the structure formula for your butene in two ways. You could either write it simply like this, similar to what we have written for pentane, or you could actually show the double bond explicitly. So both of these would be fine in your exam. I personally prefer this notation because it really makes it clear that this is where the double bond resides. Over here, you would have to see for yourself, but anyone who is already very familiar with organic compounds would know that the double bond resides here, because this carbon, which is on the terminal, usually has a methyl group. It's basically a methyl group, but in this case, it is not methyl group, it is methylene, it is CH2. So definitely to complete carbon's octet, there must have been a double bond here. However, you can go with either of these, it's completely fine. Okay, the next thing we talk about is the displayed formula. Now, this is perhaps one of the most important formulas that you will come across in this video, because in the entire course of organic, we definitely love making these displayed formulas. This formula basically represents all the bonds. Another very important statement, it shows all the bonds within a molecule. So for example, in this case, you can see we have pentane, right? But in this case, we are showing all the bonds, all the CC bonds and all the CH bonds. We're not leaving out any group. Now, in this case, if you choose to draw this in this way, which is like this, and then perhaps you write CH2, 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 and then you write CH3. Now, this thing right here is not a displayed formula, because in this case you're not showing all of the bonds, you're not showing the CH bonds over here, here, or here either, right? So remember that the displayed formula represents all the bonds, and you cannot miss out any single bond, otherwise you have basically written the wrong thing or drawn the wrong thing and you won't get the marks. Okay, let's look at butene now. Now in butene, you can clearly see that we have CH2 and then a double bond in CH and then all of these bonds, right? So nothing much difficult. Similar to the structure formula, we have drawn the displayed formula, we have drawn the double bond, and you can clearly see that the 4 bonds that every carbon has to make is being fulfilled. So 2 bonds with hydrogen, double bond with this carbon has double bond here, one bond with this hydrogen and 1 bond here. So every carbon has 4 bonds being formed, and so its octet is being completed. Okay, the last thing, which is perhaps a new thing that you will go over in AS Organic, is the skeletal formula. Now, this perhaps becomes one of the very easiest formulas to write down only if you have sufficient practice. Now, we say that the skeletal formula is basically the simplified version of the displayed formula. So you can see writing this entire thing for a very, very huge molecule, such as, let's say, if I have 20 carbons. Drawing this for a 20 carbon molecule will be a very tedious process. So instead we go for the skeletal formulas, because I believe that chemists are slightly lazy. However, this does bring with it some new rules that you need to keep in mind. So the first rule to keep in mind is that you will draw all the carbon-carbon bonds as straight lines, and you will not show any CH bonds, and you will show all other bonds which are not CH bonds. So this might look intimidating, but let's do some examples and hopefully it will get more clear. So let's start off with this first molecule. This was supposed to be pentane. Now, how do we draw out pentane? So just for your ease, I will first make its displayed formula, all right, and then make its skeletal formula to make it more clear. So I hope all of you are very comfortable with drawing displayed formulas. This is the displayed formula for pentane. Now, when we are drawing our skeletal formula, remember that all CC bonds will be represented as straight lines. So this is one CC bond, this is another CC bond, here's another CC bond, and here's another CC bond. Now, if you look over here, you can clearly see you have 1 bond, 2 bond, 3 bonds, and 4 bonds between carbons, obviously. So 1 bond, 2 bond, 3 bond, 4 bonds. If you don't like it in this way, you can also consider all of these ends to be a carbon atom. So you can clearly see that these count up to 5 carbons, which is the case in our displayed formula as well. And that is about it. That's how you draw pentane. You can clearly see that all we are doing is showing the CC bonds as straight lines, and we are not showing the CH bonds. They're basically implied. Okay, so I hope that this is clear and you can clearly acknowledge the fact that drawing these skeletal formulas is a very easy task, and it is also, it kind of saves a lot of time when drawing a lot of organic structures. Okay, let's go for the second basically example, which is butene. So let's say I'm going to make but2ene again. Let me get rid of that. So let's make 4 carbons first, and now let's complete their octet. All right, now as you can see, first of all, let's draw out all the CC bonds over here. So this is our first CC bond, this is our second CC bond, this is our third CC bond. Now, as you can clearly see, there are only 1, 2, 3 CC bonds over here, right? In other words, the number of lines that you will draw will always be 1 less than the number of carbon atoms which are in a molecule. If that helps, do that. And you can also see that every corner is a carbon atom. So you can see there are 4 carbon atoms over here, just like what we expect in butene. Now, the double bond is located right over here. So what we will do is we will represent this double bond as it is over here as well, like this. All right, and obviously because all of the bonds are CH bonds, we will not be showing them, and it is already implied that there are 3 CH bonds here, there is 2 CH bond here, there's 1 CH bond here, and there are 2 CH bonds here, because you have to basically see as long as you're not exceeding carbon's octet, you will see how many hydrogen atoms are implied in each place. Okay, now let's look at the example of C2H5OH. This is basically ethanol. So drawing this out, we first make our 2 carbons and draw our hydrogens next to them. So these are 5 hydrogens, and then we basically have an OH group attached. Notice how I made a proper displayed formula. If I was to basically remove this and write my OH like this will not be a proper displayed formula, because I'm not showing the OH bond clearly over here. I'm not drawing the OH bond. So in its truest sense, this will not be a displayed formula. This thing right here will be a displayed formula. So as far as its structure, its skeletal formula is concerned, we only have, as you can see, just 2 basically carbon atoms involved, or a single CC bond. So I just drew it like this. Okay, and all of these CH bonds are implied, so I won't be drawing them out. However, you can clearly see that there is with this carbon, you have an OH group attached. And so in order to show that bond, you will draw a line and write OH. So what does this mean? This means there's a carbon over here and there's a carbon over here. And with this carbon, there's a OH group attached. All right. And in order to complete the octet of each carbon, you can clearly imply that there will be 3 hydrogens over here and there will be 2 hydrogens over here. So then again, I hope that the skeletal formula is getting more clear to you. Now let's go move on to what we have below. This is basically our bromoethane. You don't need to know the name right now, because as I said, we will be going over the nomenclature in one of our coming videos. However, if I were to draw its basically displayed formula, it would look something like this. So very similar to what we have above, but with the only difference that instead of the OH group or the hydroxyl group, we have bromine attached. Now, drawing its skeletal formula, we get something similar to what we had above, but in this case, we have a CC single bond, but in this case, our bond over here is with bromine and not OH. Similarly, let's do a little bit more difficult example right over here. So this right here is basically a methyl group, and next to this methyl group, we have a CH group, and you can clearly see that with this carbon, there's a methyl group attached at the top as well. So with this carbon over here, we have a CH3 group attached as well. But definitely, I won't be writing this down as CH3 only. I will expand this in a minute, because otherwise it won't be a true displayed formula. Okay, and this thing would become CH2 then, and then we have CH2 again. And next to CH2, we have Br. Now, in order to make this a true displayed formula, I will remove the CH3 over here. and write it properly like this. Now this is the displayed formula, the true displayed formula, and now let's make the skeletal formula. Now first count the number of carbon bonds. We have 1 bond, 2 bond, and 3 bonds. Okay, now in this case you might be wondering, well, what about this methyl group? Well, in this case we will look at the longest carbon chain. In this case we get 4 carbons, and if I go like this, I get 3 carbons. So I want to go for the longest carbon chain, and this is 1, 2, and 3. Or you can otherwise say that you have 4 carbons involved. So I will be drawing out 3 lines, so 1, 2, and 3, and this will basically show our 3 CC bonds, 1, 2, and 3. And then next to this carbon you can see that a bromine is attached, so I will draw that bond now. So similar to what we have done above, I just drew a line, and with that line I wrote basically next to it Br. Now lastly, don't miss out the fact that there's a methyl group attached to this carbon as well. So what we will do in this case is that you can see that if I were to number these 1, 2, 3, 4, and why am I numbering it like this? You might remember that whenever you have a functional group attached, you give that carbon more preference and you want to give it the lowest possible number. So 1, 2, 3, and 4 like this. All right. Anyways, the important thing is this numbering I've done only to make it easier for you. The important thing is to realize that with this carbon, which we have labeled as 3, there's a methyl group attached. And so to draw that out, I will basically take this carbon and draw a line over here. Now, you can clearly see that this line over here, I've not written CH3, right? Because I don't need to write CH3. As we know that we do not draw our CC bonds, right? We don't draw our, we do not show or write our carbons in our skeletal formula, and neither do we show our CH bonds at all. So therefore, many a times whenever you get to see just a single line which is basically protruding out of a organic molecule, it is implied that this thing will be methyl, all right? And if had it been something like this, then you can clearly see that if you follow it, you have one CC bond and another CC bond. So this means this is ethyl. Now definitely as we go along this course, this might be looking a little bit intimidating right now, but as we go along the course, you will realize that these formulas, skeletal formula, is actually a very easy and convenient way to draw out our organic molecules, provided that we are comfortable with drawing it. Other than that, in the next video, we will most probably be talking about nomenclature. If you like this video, then maybe give it a thumbs up, subscribe to the channel, and hit the bell icon. All of these notes will be made available on our blog. The link for that will be provided in the description box below. In case you want to book one-on-one sessions with any of our instructors, you can also use the link below to our Instagram handle and basically DM us and just book your session over there. So till the next time, Khuda Hafiz, take care.